43, you have the equation y equal ln x squared. And let's see so we're going to do on 43, we're going to do the same thing we just did on 41 that we worked on the board. All right. And it's so similar, it's going to help us get this idea, I think. If I take the derivative, if f of x is ln x squared, and I take the derivative of ln x squared, remember the form that we do is it's like you're looking at this as ln u. So my u is my x squared. And so the derivative is it's the derivative of that u over the original u, okay? So what would it be? What's the derivative of u if u is x squared?
Oh, the derivative of u? 3 halves x to the 1 half.
On this x squared here?
On what? Oh, is it x squared?
Yeah, on 43. Am I on the wrong?
I'm looking at 42. That's what
Oh, yeah, okay, yeah, 43.
It'd be 2x.
It'd be 2x. If u is x squared, the derivative of u would be 2x. I'm going to put 2x over my original u. My original u is x squared, but that reduces. Okay, I don't want to leave it like that. Wouldn't that be 2 over x?
Yes.
Okay, so there's my derivative. And now they want me to write the equation of the tangent line through this function, through that point. So I needed the derivative because the derivative is the slope of the tangent line. Okay, my point is 1, 0, right? Okay, so my slope is 2 over x. Yeah, you just plug in x as 1. Yeah, you get 2. You're right. So there's my slope. And now I go, okay, I got to plug it into, I got to write an equation of a line, and this is the preferred way we write equations of lines in calculus because it's just helpful. Slope is 2. What's your x value up here? 1, so it's x minus 1. Y value is 0, so I could put y minus 0, but it's just y, right? So I'll go ahead and write it in case somebody's watching it that needs to see that step. And that would just be y equal, what, 2x minus 2? All right, so we're supposed to take the derivative. So here we're going to use our log rules. This is why they had us practicing those log rules at the beginning of this lesson. This is two things multiplied together. It's like ln u times v. And if you remember, we can split that up into, that's the ln of x plus the ln of the square root of x squared minus 1. So I'm going to first use my log rules to split it apart because how are we going to attack that? We don't have any rules. Or maybe we could do something different with it, but this is how you typically attack this, okay? Now, of course, that second one, we don't have derivative rules for radicals, so I'm going to write that as ln x squared minus 1. Remember, the square root is the same thing as raising something to the 1/2 power, right? Okay. I am going to stop the video and tell you what I did that I did not have to do. Well, let me go ahead. Let me go one more step first. All right. Now, the log rules also say that I can take that 1/2 and I can drop it out front, right?
And that's not dropped out in front of the entire thing. That's just in front of the second.
Correct. Just in front of the term that it was on, okay? Now, here's what I did, and I'll leave the video running. I guess it might be helpful to hear this on the discussion. Couldn't you factor x squared minus 1 into x minus 1, x plus 1?
Yeah.
And then you could split that up into two separate logs. That's what I did, but you didn't need to do it. That was way, way overkill, okay? So I did that, and then I checked my answer, and I'm like, wow, my answer was very spread out looking. Theirs was not. So I'm like, what did they do differently? So here's what they did differently. What they did was this. They said, okay, we're just going to, you got two different terms, so we can take the derivative of each term. So we're going to take, I'm going to change this to f of x. I just don't like that y notation. I'd rather look at it like this, and it's just a personal preference here. If I take the derivative of ln x is 1 over x, right? All right. I got a 1/2 out front, so I can put the 1/2 and then take the derivative of ln x squared minus 1. If you split this sucker apart, you get a lot more terms you got to mess with. You could just do this. If the derivative of this, I could look at it as u is equal to x squared minus 1. It's not too hard to take the derivative of u. It's just, what, 2x? So this is going to be a half. The derivative of u, remember it's u prime over u. The derivative of u is 2x. Yeah, I had a really long expressions because I split it apart. I really honestly still, as a teacher, do not have the feel for when should I quit simplifying. Just because I could break it apart, it wasn't needed here, I guess, is what the lesson learned from that was. Now, that is the derivative, but they want you to express it as a fraction, a single fraction. So we have to get a common denominator, because aren't we adding fractions here? Lovely. Here's come the fun times, okay? Now,
Distribute the 1/2 first or not?
you could, and actually let's go ahead and do that. I think that probably would be better. Let's go ahead and do that. That's going to be what? 2x over 2x. I'm going to leave it as 2x squared minus 1. Oh, wait a minute. Yeah, I'm going to leave it like this. And the reason is if I got to get the common denominator and I make that 2x squared minus 2, I think it makes the math harder for me anyway. So I need to get a common denominator. I've got the 1 over x. It needs to be multiplied by 2 times x squared minus 1 over 2 times x squared minus 1, right? That's what the other denominator has that it doesn't have. Okay? And then I've got 2x over, I'll do this one a different color, 2 times x squared minus 1. And what does it not have that the other one has? They need another x. So I need to multiply by x over x. I sure wish these characters would pick up. So here's where it just gets a little messy. That's on the top, I've got 2x squared minus 2. And then plus over here, that's plus 2x squared, I guess, yeah. And on the bottom, we have x times 2 times x squared minus 1. Let me just write that as the 2 and the x together times x squared minus 1. So it's not too bad, I guess, but on the top, 2x squared plus 2x squared would simplify into 4x squared. And then I have a minus 2 there, right? And on the bottom, I have 2x times x squared minus 1. Again, I'm not going to multiply that out because I'm kind of thinking that top looks factorable. And I can factor a 2 out of the top, can't I? And that would be 2x squared minus 1 over 2x times x squared minus 1. And then I could cancel the 2's out, right? So it ends up being this, I'll just circle the part that's left. This is what it ends up being right here. And you could multiply x times x squared minus 1 and get what, x cubed minus x on the bottom. But they actually, I think they left theirs this way too.
Okay, but they both mean the same.